All right, people. Yesterday you might have not got done with everything, but we're still moving on because this next uh, assignment is just 4 problems. So shouldn't take you very long to do. So yeah, so finish section 2.5a if you're not done yet, and then let's do 2.5b. Okay, number one, it says 3i is a root. So if we know from yesterday, if 3i is a root, negative 3i is also a root. The sum of those roots is 0. Their product is negative 9i squared, which, if we do the sum product of the roots, we get x squared plus 9. Okay, equals 0. All right, so how does that work with this? Well, if we use polynomial long division like we did a few days ago, where we have x squared plus 0x plus 9 here, and then x to the fourth plus 0x to the third plus 2x squared plus 0x minus 63 here, we can find the trinomial that works for this. So what times x squared is x to the fourth? Well, it's x squared. If we distribute, we get x to the fourth plus 0x to the third plus 9x squared. At this point, we change the signs to the bottom row and then add, and get negative 7x squared plus 0x minus 63. What times x squared is negative 7x squared? Well, negative 7 is. So you get negative 7x squared plus 0x minus 63. Change the signs to the bottom row and then add, we get 0. So x squared minus 7 equals 0 is our other binomial. And then if we solve this, we just take this to the other side. X squared equals 7, take the square root. X would equal positive or negative square root of 7. So the zeros are 3i, negative 3i, 7, and negative 7. Okay. The low linearized factorization of this, I think what they want is the x squared plus 9 times x squared minus 7. Let me see. Oh, nope. They want it even further. They want x plus 3i times x minus 3i times x plus square root of 7 times x minus square root of 7. This is the answer that goes into that box. Yes, Dan. Boys are going to Millbank at 10:15. 3:30. Varsity game. Probably 7:30 or 8. Okay. All right. Sounds good. Thanks. Bye. Sorry for the interruption. We're trying to figure out bus schedules. All right. So, write the function as a product of a linear and irreducible quadratic factors. Okay. So, what do we get here? Well, we use synthetic division. 1, negative 10, negative 10, negative 11. So I'll try a 1 in here first. So I get 1, 1, negative 9, negative 9, negative 19. And we see that doesn't work. So we get rid of it. And we try negative 1. And we get 1, negative 1. And then we get negative 11, which is 11, which is 1, which gives us negative 1, and that's 10. And that doesn't work. Doggone it. Did I do everything right? Yeah, I think I did. So the other factors are negative 11. So 1, negative 11. That's negative 21. That's a huge number. That won't work. Let's try positive 11. So we got 11, which is 1, which is 11, which is 1, which is 11, which is 0. Hey, it worked. Okay. So 11 is a factor, and we're left with, if this is x cubed, we're left with x squared plus x plus 1. Okay. How is that factor? It doesn't. Quadratic formula, here we come, because I want to know, well, yeah, I want to know another way of doing it. So negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so it's negative 1 plus or minus square root of 1 squared minus 4 times 1 times 1, which is 4, over 2 times 1, which is 2. So it's 1 plus or minus negative 3, the square root of negative 3 over 2. So it's 1 plus or minus I square root of 3 over 2. So what do they want for this one? Oops, excuse me. Just like that. Come on, paper, move. They want, oh, they just want that. I already had that. All right, good enough. So this is just x minus 11 times x squared plus x plus 1. Okay? All right. There's one, and then there's one. So let's do this last one here. Okay, possible factors of this. So we have 1, 3, negative 1, 9, negative 12. Possible factors are plus or minus 1, 2, 3, 4, 6, and 12. So there's a lot of them. So let's try 1 first. 1, 1, 4, 4, 3, 3, 12, 12, 0. Yeah, that worked. Okay, so there's one of our factors. And now we have, should we try it again? We can't try it again because if they're all positive numbers, it would just keep getting bigger. So let's try negative 1. So 1, negative 1, 3, negative 3, 0. That doesn't work. So then let's try negative 2. 1, negative 2, 2, negative 4, negative 1, 2. Not quite, but we're getting closer. Negative 3. 1, negative 3, 1, negative 3, 0. Doesn't work. Try negative 4. 1, negative 4, 0, 0, 3, negative 12. Booyah. Got it. So now this was x to the fourth, this was x to the third, this is x squared. So what we're left with is x minus 1, x plus 4, and since x squared plus 3 equals 0 gives us factors of square roots, it's yeah, we can't reduce it. So well, I wonder. Let's go x squared equals 3, negative 3. Take square root of each side. So x equals plus or minus I square root of 3. So it's x minus I square root of 3 and x plus I square root of 3. But it has to be real coefficients. So we don't want that. So it's just x squared plus 3. There we go. That should be the answer. Real coefficients, Mr. Bierschbach. And there it is. Okay. So that's the basics of what we're doing on these 4 problems. Okay. So there you go.